Hi, welcome back to the course Data Science by Ralph Fabric. And today, let us look at statistics and probability in data science. What is statistics? Statistics is the science of how to collect, organize, and interpret numerical information from data. In the last lecture, we looked at what is data and how can data be managed. Now let us look at how we can get information by using statistics from data. The official definition of statistics is that it provides a body of principles and methodology for designing the process of data collection, summarizing and interpreting the data, and drawing conclusions or generalities. Now let us look at how statistics is in data science. Statistics helps us make sense of data. We have a lot of data, and statistics brings us to a conclusion and helps us come to a decision. In data science, these decisions are the outputs or predictions from the models. There are two types of statistics: descriptive statistics, which involve methods of organizing and summarizing data and presenting numerically or visually, which are tables, charts, and averages. In this course of data science, we will not be looking more deeply into descriptive statistics as it's only a visual thing. Most of the machine learning models will be using something called inferential statistics, which involves using sample data to draw conclusions about a population. For example, making predictions on certain measures. Now let us look at randomness. Random phenomena is a situation in which we know what outcomes can possibly occur, but we don't know which particular outcome will happen. For example, this could be approaching a traffic light. You know that there is red, orange, green signal, but you're not sure which one will actually see when you approach the traffic light. Now let us look at some probability vocabulary. First, we have experiment. Experiment is any process, real or hypothetical, in which the possible outcome can be identified ahead of time. Trial. In each occasion which we observe a random phenomena, the value of the trial is called the outcome. So if we take an experiment and we conduct trials on the experiment, and we combine all these trial outcomes, we will get something called event. These combinations can also be sometimes called as set. A sample space is the collection of all possible outcomes denoted by capital S. In another word, S is the set of all possible outcomes. Let us look at some of the examples of randomness. We can consider an experiment of flipping two coins. The trial is flipping two coins. The outcomes is either heads or tails for each flip. The sample space, S, is the set of, it could be heads and heads, it could be heads tails, tails head, or tails tails. The event is, one possible event that may occur is heads tail. Now let us look at how to find probability. One of the interpretations of probability is the frequency interpretation, which states that the probability that some specific outcome of a process can be interpreted to mean the relative frequency. Let E be an event in the sample space S, then the probability that event E will occur is defined by probability of E is equal to number of outcomes in event E divided by total number of outcomes in the sample space. Now let us look at what is a formal probability. There are a couple rules for formal probability. Rule number 1 is, let A be any event in the sample space, then probability of A lies between 0 and 1 or 0 to 100%. Rule number 2, if S is the sample space of a given experiment, then probability of S is equal to 1. That is because the set of all possible outcomes has probability of 1. For example, when tossing a coin, there is a 100% chance that you will get a head or a tail. Rule number 3, let A be an event in sample space S. The set of outcomes that are not in event A but are in sample space S is called a complement of A, or sometimes called as A naught. This is usually the probability if there's only two cases, 1 minus the probability of A. Rule number 4, the addition rule. Suppose you have two disjoint sets or mutually exclusive events, A and B, in the sample space S, then the probability of occurrence of at least one of them is A probability of A plus probability of B. If the events A and B are independent, then the probability that both A and B occur is the product of the probability of two events, which is probability of A and B is equal to probability A times probability B. Here are some common mistakes in probability. Beware of probabilities that do not add up to 1. If they add to less than 1, look for another category, because you might be missing a category in the set. If they add up to more than 1, maybe they are not disjoint, maybe they are independent. Do not add probabilities of events if they are not disjoint. Events must be disjoint to use the addition rule. Don't multiply probabilities of events if they are not independent. Don't confuse disjoint and independent. Disjoint events are never independent because disjoint events are mutually exclusive. Conditional probability is a really important concept as we will be using them when we are talking about Bayes' theorem and naive Bayes in machine learning. Suppose that we learned that an event B has occurred and that we wish to compute the probability of another event A, taking into account that we know that B has occurred. For example, if I took a chocolate from a pile of 5 chocolates, what's the probability someone will take another chocolate? The new probability of A is called the conditional probability of event A, given that event B has occurred, which is denoted by probability of A given B. For conditional probability to occur, the probability of B should be greater than 0. And the formula for conditional probability is that probability of A given B is equal to probability of A and B divided by probability of B. When event A and event B are independent, the formula will change into probability of A times probability of B divided by probability of B. Or you can just simplify it as probability of A. I hope this was informative. To learn more about data science, please visit routefabric.com. Thank you.